Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. This is the sixth video in the series of videos on the solution to paper 3 questions for AAHL, and in this video I will be solving question 2 from May 2021 time zone 2 paper 3. So we have 5 videos before this, and the links to all these 5 videos are given in the description below. And these videos are from Specimen paper 3 questions and May 2021 time zone 1 both the questions, and the first question from May 2021 time zone 2. And in this video I am going to solve the question 2 of the same paper. In all these videos I will be giving you some tips on time management and thinking process along with the solutions. So before we start, please have a printed copy of this question in front of you. You can have a notebook and a pen with a GDC so that you can solve the question along with me. That will be more helpful for you to understand the process of solving these question papers and also how to manage the time. So let's get ready for solving this question. This question carries 24 marks maximum. So in my previous videos I have explained how to calculate the time for each question. In this case, for 24 marks you have around 24 to 26 minutes to solve this question. So get ready with that time limit in your mind, and then let's read the first statement given in this question. This question asks you to investigate and prove a geometric property involving the roots of the equation z power n equal to 1, where z is a complex number and n is an integer greater than or equal to 2. So we are going to start with n equal to 2, then n equal to 3, n equal to 4, and so on, and we are going to solve the equations in the form of z square equal to 1, z power 3 equal to 1, z power 4 equal to 1, etc. And what we are going to find here is we are going to find the roots of the equation z power n equal to 1, where z is a complex number and n is greater than or equal to 2. So solving for the roots of the equation for these equations, and we are going to prove a geometric property involving these roots. So first of all, let's consider what we know about z power n equal to 1 for n greater than or equal to 2. So the first n value will be 2, therefore the first equation will be z square equal to 1. Solving this equation, you will have the roots to be plus or minus 1. That's very easy to do. So it's not in the question, but we are going to collect our thoughts to understand what is given in this statement. So we are going to understand what it means by roots of the equation z power n equal to 1 for n greater than or equal to 2. So first case is n equal to 2. So the first equation is z square equal to 1, and therefore the roots of this equation is plus or minus 1. This we know already. The second equation will be z cube equal to 1, for which the roots are going to be 1 omega and omega square. We have done this under the nth root of unity chapter under complex number topic. So you know that cube root of unity is 1 omega and omega square, and the fourth root of unity is 1 omega omega square and omega power 3, and so on. We have done this in complex number topic, and you are going to collect all these together now on your rough paper. Once you know that this question is going to involve the nth root of unity, you can think about complex numbers in geometrical approach, which is going to be on Argand diagram. So you are also going to have Argand diagrams to be drawn for this question, because we are going to investigate a geometric property of the roots of the equation. So the roots of complex equation will be on the real and imaginary axis as here. So for example, the roots of z square equal to 1 can be represented on the real axis like plus 1 on the right side of origin and minus 1 on the left side of origin. Therefore this is the Argand diagram, and this is the representation of the roots of z square equal to 1. And you can also try to represent z cube equal to 1 roots and z power 4 equal to 1 roots on the Argand diagram before we proceed further. So you can pause the video here and try to represent the roots for the 3 equations given here. Proceeding further, we are given another information here. The roots of the equation z power n equal to 1 for z in complex number set, the roots are going to be represented as 1 omega omega square and etc. up to omega to the power of n minus 1, because you have n roots for the nth root of unity. The first root is 1, the second root is omega, the third root is omega square, and so on. The nth root is omega to the power of n minus 1. And in this case, it's given that omega is equal to e to the power of 2 pi I over n. So this is the information we are given here, and we can also see that we are going to represent all these roots on an Argand diagram, which we will see a little later. But at the moment, let's understand what this e to the power of 2 pi I over n mean. So when z power n equal to 1, we can write 1 as 1 plus 0i. So z becomes 1 plus 0i to the power of 1 over n. Let's think about how we solve the nth root of unity, and this is how we do it. We find the modulus and argument of 1 plus 0i, which will give you 1 cis 2k pi, or e to the power of 2k pi I. This is in polar form and this is in exponential form. So we have both the forms written here for 1 plus 0i. Now since z equal to 1 plus 0i to the power of 1 over n, you can either use polar form or exponential form, but I'm going to use exponential form here because it's given in the question in that way. So the exponential form of the roots of the equation 1 plus 0i to the power of 1 over n will be e to the power of 2k pi I over n, where the k values range from 0 to n minus 1. As you change the values of k, you will get all the n roots of 1 power 1 over n in complex set. This result is obtained from de Moivre's theorem. So you can use de Moivre's theorem to find the nth root of unity in this way. We have done this in complex number topic. So just recollect those information and write it down in your rough paper before we proceed further. So for k equal to 0, the root is going to be 1 because e to the power of 0 is 1. When k equal to 1, you will get e to the power of 2 pi I over n. This is the second root and we call this as omega. When k equal to 2, the third root is e to the power of 4 pi I over n, which is obviously equal to the square of omega, and so on. So if you substitute the value of k as 0, 1, 2, etc. n minus 1, the corresponding roots are going to be 1, omega, omega square, etc. omega to the power of n minus 1. And these are the roots of, actually these are the n roots of the equation z power n equal to 1 in complex number set. So this is all we know about the nth root of unity and how to solve nth root of unity and what are the roots of the nth root of unity, etc. And next we are going to see how we can represent this on an Argand diagram. So it says P0, P1, P2, etc. are the points corresponding to 1 omega, omega square, etc. Therefore, if you represent these points on a unit circle like this is unit circle because it's the nth root of unity, the modulus of 1 is 1. Therefore, this is all going to be on the circumference of a unit circle. So we are representing the roots P0, P1, P2, P3, P4, etc. on the circumference of this unit circle on the Argand diagram. And you can also see that P0 is 1. Therefore, it is on the real axis. P1 is e to the power of 2 pi over n, and this is going to be called as omega. And we just saw that P2 is going to be omega square, etc. P3 will be omega cube, P4 will be omega power 4, etc. And therefore, these points P0, P1, P2, P3, P4 can also be written as 1 omega, omega square, omega cube, omega power 4, and all the way up to omega power n minus 1. And this is the Argand diagram representation of all the roots of z power n equal to 1. Now, is it going to be like this always? No. As the value of n changes, the number of roots also change. For example, if you have n equal to 3, there is not going to be any P3, P4. It's only going to be P0, P1 and P2 because there are going to be only 3 roots for n equal to 3. So these 3 roots P0, P1 and P2 will be equally spaced on the unit circle. So you will not have P3, P4, etc. but you will have only 3 roots. It will be in different positions for different values of n. So this is what you need to think at this moment. So collect all these together and write it down in your rough paper. So this is very important for every question in paper 3. Before you actually read the question, for every statement or every information given in this question, spend some time, a minute or two, to collect all your thoughts about that statement. Whatever you know about that statement, write it down in a rough paper and keep it ready for reference throughout the solution. So let's proceed further to see what the question is, and still there is one more information given in the question paper. The example given is for n equal to 2, z square equal to 1. We already saw that z square equal to 1 is going to have solutions plus or minus 1. In this case, it's given as 1 and omega. So 1 is plus 1, omega is minus 1. And it's also given that the root 1 can be represented as P0 and root omega is P1 on the Argand diagram. So let's make the Argand diagram now. The roots are plus and minus 1. It's also named as 1 and omega in this case. Therefore, if you draw the Argand diagram, real and imaginary axis, P naught is on the right side of the origin and P1 is in the left side of the origin. So 1 is P naught and omega is P1. We have done this already a few minutes before. So 1 comma 0 is the coordinate for P naught, minus 1 comma 0 is the coordinate for P1. So this is all you can think about from this statement given above. So in the same way, this is also going to be on an unit circle. Therefore, the radius is going to be 1 unit. The center is going to be the origin 0 comma 0. So these are the information you can again think about just after the statement. So don't just read the information given in the questions. Spend some time to collect your thoughts about that information and make a simple note on your rough paper. So this is again given in your question paper. For n equal to 3, they have given you the diagram itself. So for n equal to 3, you have 3 roots, 1 omega omega square. Now these 3 roots are placed on the Argand diagram over the circle of radius 1 unit with the center as 0 comma 0, and you know all these things because you have thought about all these things before itself. When you see the diagram given on the question paper, you can understand this very easily. Now P0, P1, P2 are given on the circle of 1 unit radius. So what is P0, what is P1 and what is P2? P0 is 1, P1 is omega and P2 is omega square. This is how it is represented on the Argand diagram. Now let's go a little further and see what is P0. P0 is 1 and what is P1? P1 is 2 e to the power of 2 pi I over 3 because n equal to 3. You have P1 as e to the power of 2 pi I over 3. Simplifying this using cos theta comma sin theta, the coordinates of omega will be minus half comma root 3 over 2. Similarly, for P2, the value is e to the power of 4 pi I over 3. Omega square is e to the power of 4 pi I over 3 here because n equal to 3. And simplifying this using cos theta comma sin theta, the coordinate is going to be minus half comma minus root 3 over 2. This is something that you can take note of at this point of your question paper. So again, write this down in your rough paper so that it might be helpful later. Let's proceed further. The first question, after all this information given to you and you have spent around 3 to 4 minutes to collect all the thoughts about the information given so far, now it's going to be very simple to solve all these questions that is coming up. You can see that the first question is extremely simple. It's just asking you to expand the 2 brackets and simplify this to omega cube minus 1. It's a very simple question. Pause the video here and try to do it within half a minute. So let's continue. Multiply term by term, simplify, cancelling out the equal terms, and you get omega cube minus 1. This is just in few seconds you can complete this question. So you're saving a lot of time in this question. Next question is hence question. Therefore, you are going to use the previous result. And in the previous result, you have omega minus 1 times the quadratic is equal to omega cube minus 1. So in this question, you should note that n equal to 3. Therefore, the roots are 1 omega and omega square for the equation z cube minus 1 equal to 0. This is what you have at the moment for this question. So we are in the position where n equal to 3 and the equation is z cube minus 1 equal to 0 or z cube equal to 1 is the equation. The roots are going to be 1 omega and omega square, and in this case we are going to prove that omega square plus omega plus 1 is equal to 0. So if you compare this with A1, you can see that there are 2 terms, omega minus 1 and omega cube minus 1. So what happens to omega minus 1 and omega cube minus 1 in this case? Since omega and 1 are 2 different roots, omega cannot be equal to 1. Therefore, this gives you that omega minus 1 is not equal to 0. So that part of the statement in A1 is not equal to 0. And also we have, since omega is the root of z cube minus 1 equal to 0, omega can be substituted for z, giving omega cube minus 1 equal to 0, which means this part of the A1 is equal to 0, whereas this part is not equal to 0. Just we saw that since omega is not equal to 1, omega minus 1 cannot be equal to 0, but omega cube minus 1 is always equal to 0 because omega is the root of z cube minus 1 equal to 0. Therefore, the only part left out is here, and that has to be 0. Therefore, we get the result omega square plus omega plus 1 is equal to 0, which is what we want for this question. So this is slightly tricky. You need to understand that we are in n equal to 3 position. So when you are going to think what to do, you just go back. Since it is a hence question, you go back to the A1 question. Which part of the A1 question is required? We required omega square plus omega plus 1 part. The remaining parts are supposed to be removed, and you think about what happens to omega minus 1 and what happens to omega cube minus 1. If you think in this root, you will understand that you have to proceed in this way where omega is not equal to 1 and omega is the root of z cube minus 1. In this case, you will have reason marks for writing omega minus 1 is not equal to 0 and reason for writing omega is the root of z cube minus 1 equal to 0. Therefore, omega cube minus 1 is equal to 0. So, you will not get answer marks because it's a deduced question. So, you will have 2 reason marks for writing the 2 parts of the equation. Let's proceed further. There is another information before question B. It says we are going to connect P0 and P1 and P0 and P2, and the lengths of P0 P1 and P0 P2 is given, and we know that P1 is omega, and we also considered what is the coordinates of P1 and P2 just now, and we know these are the coordinates. Let's write the coordinates here. You are given that P0 P1 and P0 P2 are the lengths between P0 P1 and P0 P2. Therefore, in order to find the lengths P0 P1 and P0 P2, which is here, you will be using distance formula between the 2 coordinates. So, P0 is 1, 0, P1 is minus half, root 3 over 2, P2 is minus half, minus root 3 over 2. So, collecting all these information together, you can use distance formula to find P0 P1 and P0 P2. Here you are going to pause the video and you are going to find the length P0 P1 and P0 P2 and substitute in B question to see that the product gives you 3. So, pause the video here and continue later after finishing the question. Therefore, the solution is P0 P1 is going to be root 3 and P0 P2 is also going to be root 3, and multiplying root 3 times root 3 is going to give you 3. Therefore, this is what we want. We have got the result. This might take 2 to 3 minutes because you need to think about the coordinates of P1, P2 and P0, and also you have to think about distance formula. The moment you see the word length between the 2 points, you should think of distance formula. The moment you think about distance formula, you need the coordinates. So you can think backwards and you can see that first thing that you need is the coordinates of P0, P1 and P2, which can be obtained using the cos theta, sin theta form of the roots. Let's proceed further to the next question C. Again, before question C, there is another information given. You are given that we are in the case n equal to 4. Therefore, the equation is z power 4 equal to 1 and the roots are going to be 1 omega, omega square and omega power 3. Now again, pause the video and think about what are these roots going to be. But since this is only for 2 marks, it's going to be a very simple question. So don't think too much further. Just read the question. We are asked to factorize z power 4 minus 1. Before you actually try to factorize it, look into how you can factorize it. I'm going to factorize this in this way, z minus 1 times a cubic. Why am I doing this? Because if I look at question A1, I can see that z cube minus 1 is factorized as a linear factor times a quadratic factor. So even though I can factorize z power 4 minus 1 as z square minus 1 times z square plus 1 and etc., you can do the factorization in many methods, but this will be the most appropriate method in this question because it follows the pattern from question A. So always remember to follow the pattern in these questions. So the pattern is you have to write z power 4 minus 1 as a product of z minus 1 times a cubic polynomial. So in order to find the cubic part of the factors, you can divide z power 4 minus 1 over z minus 1 using polynomial division method. You can find that the second factor is going to be z cube minus z square plus z plus 1. And this is very simple because it follows the pattern from question A. Once you are done with this, you know that you have to represent your results in terms of omega, but you have it in terms of z. So what is the connection between z and omega? Omega is a root of z power 4 minus 1. Therefore, z can be substituted as omega here. So instead of z, I can write everything in terms of omega. So omega power 4 minus 1 can be written as omega minus 1 times the cubic polynomial in omega. Now, following the same steps as you followed for A2, omega power 4 minus 1 should be equal to 0 because omega is the root, and omega and 1 are different roots. Therefore, omega minus 1 cannot be 0. Therefore, the only 0 part is omega cube plus omega square plus omega plus 1 equal to 0. And these are the things that you should show on your answers. This question will have 1 answer mark for factorizing z power 4 minus 1 and 1 reason mark for giving the omega power 4 minus 1 is equal to 0 and omega not equal to 1. So this is again a simple question. If you follow question A correctly, you can easily do question C. Let's proceed further. The next question is for n equal to 4. We are in n equal to 4 case. Therefore, there are 4 roots P0, P1, P2 and P3. In the same way, we are connecting P0 with all the other 3 roots P1, P2, P3. And we are going to show that the product is equal to 4. So again, we need all the coordinates of P0, P1, P2 and P3. In this case, z power 4 equal to 1 is the equation. And therefore, the roots are going to be 1 e to the power of 2 pi I over 4, e to the power of 4 pi I over 4 because n equal to 4, e to the power of 6 pi I over 4 again because n equal to 4. So simplifying all these things in terms of coordinates, we get plus 1 plus I minus I as the roots. And therefore, the coordinates are going to be 1, 0, 0, 1, minus 1, 0, 0, minus 1. You can see that P0 represents the root plus 1. P1 is 0, 1. It represents the root plus I because it's on the imaginary axis. P2 represents minus 1 because it's minus 1, 0 on the real axis. 0, minus 1, which is P3, represents minus I root. So we have all the coordinates of the roots. Now we need to find the distances between P0, P1, P0, P2 and P0, P3. Again, pause the video here and complete the question and come back to the video. Are you ready? So this is the product we need to find. We can use distance formula as we used for question B again to find the distance between these 3 points. Now the distance will give you these values. P0, P1 and P0, P3 values can be obtained using distance formula. But P0, P2, if you can see it, it's the diameter of the unit circle. Therefore, you can directly write that as 2. So multiplying all these values, you get the value of the product to be equal to 4, which is what we want. Proceeding further, in case of n equal to 5, we have the roots 1 omega, omega square, omega cube and omega power 4. And it's given here that the product of P0, P1, P0, P2, P0, P3 and P0, P4 is equal to 5. So what do we have so far? For n equal to 3, the product was equal to 3. And for n equal to 4, the product was equal to 4. So this is what we did in question B and D. So we are going to suggest a value for P0, P1, P0, P2 all the way to P0, Pn minus 1 where n is equal to n. So for n equal to 3 it is 3, for n equal to 4 it is 4, for n equal to 5 the product is equal to 5. Therefore naturally for n equal to n the product is equal to n. So you are going to suggest the value for this product to be equal to n. This is just one more question. Don't spend any more time on this. Just put equal to n for this question. You don't have to write anything else for this question. Going further, before question F, we have the collection of all the information that we have done so far, saying that for equation z power n equal to 1, the roots are 1 omega, omega square, omega power n minus 1. And on the Argand diagram, these roots are represented by P0, P1, P2, Pn minus 1. And we have the length segments P0, P1, P0, P2, P0, N, P0, Pn minus 1, etc. All these things we have done already. And we are also given that the circle is of radius 1 unit and the center of the circle is at the origin. Now we have to write the expression for P0, P2 and P0, P3 in terms of omega. But before this, there is an information given in the question saying that P0, P1 can be represented as modulus of 1 minus omega. So this is given in the question. We have to just follow the pattern given here and find the value for P0, P2 and P0, P3. But let's understand what this 1 minus omega means. If you look into the Argand diagram, you can see that P0, P1 is the distance between 1 and omega. So the distance between 1 and omega is modulus of 1 minus omega. Therefore, P0, P2 is distance between 1 and omega square, which can be represented as modulus of 1 minus omega square. And P0, P3 can be represented as modulus of 1 minus omega cube. So this is what your answer is going to be. P0, P2 is distance between 1 and omega square. Therefore, it is modulus of 1 minus omega square. And P0, P3 is distance between 1 and omega cube. Therefore, the distance is modulus of 1 minus omega cube. And then hence, using this pattern, you are going to write an expression for P0, Pn minus 1, which is going to be very simple because it's the distance between 1 and omega power n minus 1, which can be written as modulus of 1 minus omega power n minus 1. And this is all this question is asking you to do. And it's for 3 marks. You could have finished this in around 1 minute. So you will be saving a lot of time in this type of questions if you just understand the pattern that's given in the question. Let's proceed further to next question. Again, there is an information given on z power n minus 1. As you can see that this is being factorized in the form of z minus 1 times a polynomial in n minus 1 degrees. So this is the same pattern that was used for n equal to 3 and n equal to 4 in this question. So the pattern here is z power n minus 1 is going to be factorized into a linear factor z minus 1 and another factor with the polynomial of degree n minus 1. But the question G is asking you to change this polynomial of degree n minus 1 into product of linear factors again. So like you had z minus 1, you have to have this part which is z power n minus 1, z power n minus 2 plus etc. z plus 1 as product of linear factors over the set of complex numbers, which means this has to be represented as z minus something times z minus something else times z minus something else, etc. So you need to have them to be represented as product of linear factors in C. So let's see what we have now. We have z power n is equal to 1 having the roots 1 omega, omega square, etc. omega power n minus 1. Therefore, z power n minus 1 can be represented as linear factors using the roots like this. You can always use the roots to express any equation into linear factors. We know that. For example, any quadratic can be represented as x minus alpha times x minus beta. We have done this before. In the same way, z power n minus 1 can also be represented as a product of linear factors using the roots 1 omega, omega square, omega power n minus 1 in this way. Now compare what is given in the question and what we have here. This part is nothing but the n minus 1 degree polynomial which is given in the question. Therefore, this n minus 1 degree polynomial which is z power n minus 1 plus z power n minus 2 plus z power n minus 3 etc. plus 1 part is the same as z minus omega times z minus omega square times z minus omega cube etc. times z minus omega to the power of n minus 1, and this is going to be the answer for question 1. Question 2 is a hence question, and here we are going to use the part G1 and F, the results from these two parts, and we are going to prove our suggestion from part E. In the part E question, we suggested that the product of P0, P1, P0, P2, etc. is going to be N, and we are going to prove that using G1 and F. What is G1? We proved that z power n minus 1 plus z power n minus 2 plus etc. plus 1 to be equal to the linear factors z minus omega square, etc. z minus omega power n minus 1, product of these linear factors. This is from G1. In question F, we proved that P0 P1 is equal to modulus of 1 minus omega, P0 P2 is equal to modulus of 1 minus omega square, and P0 Pn minus 1 is equal to modulus of 1 minus omega power n minus 1. And what is part E? Part E, we had the product of all these things and we suggested that this was equal to n, and this is what we are going to prove now. Now let's take the product P0 P1, P0 P2 and P0 Pn minus 1, and using F we can rewrite this in terms of these modulus, and we know that the product of modulus is the same as modulus of the products, so we can bring all the products inside one single modulus. Now is where you have to stop and think. How do you connect G1 with this part? You can see that in G1 on the right side you have z minus omega square, etc. z minus omega power n minus 1, whereas inside the modulus you have 1 minus omega times 1 minus omega square times etc. times 1 minus omega to the power of n minus 1, which means if I substitute in this part as z equal to 1, you will get the right hand side to be the products inside the modulus. Therefore, let's say what happens when it's z equal to 1 in G1. We have the left hand side to be equal to 1 plus 1 plus 1 plus 1 all the way, and the right hand side to be equal to 1 minus omega times 1 minus omega square all the way up to 1 minus omega to the power of n minus 1. And this is what we have when we substitute z equal to 1 in G1, and this matches the result inside the modulus. Therefore, inside the modulus you can write this as 1 plus 1 plus 1 plus 1 all the way for n terms, because you have n terms in the left hand side of G1. Therefore, this is equal to modulus n. Since n is a positive integer, this can be written as equal to n, which is what we wanted to prove. So we have proved what we suggested as to be true. So this is all the question 2 is about. We have completed question 2 from paper May 2021 time zone 2 paper 3, and I hope you liked all the 6 videos and it was helpful for you to understand how to solve paper 3 types of questions. Time management is very important. Always keep a rough paper with you and take notes as and when you solve each and every question, and wherever you see some information in the question, see that you give a moment to analyze that information and write down what comes to your mind regarding that information. All this information in your rough paper is going to help you a lot in solving the question and also in reducing the time used for this question. The next set of papers, I'll be uploading the solutions to them as well. So subscribe to this channel and get updates as and when I upload videos. Thanks for watching. See you next time. Bye bye.